All right, one last type of thing they sometimes ask you to do. Let's see if I get this down. Okay. With these formulas is to verify identities like you were doing in Fix 1. All right, so for instance, suppose they want us to verify this identity, that the cosine of alpha minus beta divided by cosine alpha cosine beta, let me write that correctly, cosine beta, we want to verify that that would turn out to be 1 plus tangent alpha tangent beta. Okay, so just like we talked about, you just kind of get started trying to take the left side, for instance, and see if you can eventually get that right side to show up. Turn the left side into the right side. And remember, you don't work across the equal sign. So as you might suspect, you're going to use the cosine alpha minus beta formula. So that would be cosine alpha cosine beta plus sine alpha sine beta. So the cosine ones, they keep the cosine and the sines together, and then the sign changes. All right, and then it's all over the cosine alpha cosine beta. Now, if you have a situation like that, see how that's a product down there in the denominator? And this is a grouping symbol. So this is really a case where I need to somehow get things into two terms like I have over here. That's my goal. I always kind of glance back at that. That's what I'm trying to make happen. And see, this is a grouping symbol. This is also a divided sign. So this right here needs to go into both of those, or can be written underneath each of those. So I can put the cosine alpha cosine beta there, and then I can also do that here. Okay. All right, so let's see where that gets us. So when I'm looking at that, hey, this turned it out to be exactly the same thing, top and bottom. So isn't that equal to 1? And then look here, sine over cosine, in here, sine over cosine. So there you have it. This is going to equal 1 plus tangent alpha tangent beta with the times in between. And we verified it. Okay, let's try another one. All right, so the next one I thought would be fun to try actually is a formula we're going to use in our next section. What about sine of 2 theta? Okay, and we want to verify that that is going to turn out to equal 2 sine theta cosine theta. All right, so I'm going to start with sine 2 theta and see if I can get it to look like that right-hand side eventually. And then you might suspect we got to figure out a way to use the sum and difference formulas. So 2 theta, isn't that really theta plus theta? So now I can go to the formula for the sine of a sum, and that's going to be sine of theta cosine theta plus cosine the first, sine the last. Okay. All right. And they just happen to all be thetas, though, didn't they? And this is times, isn't it? And this is times, isn't it? So we really could leave that in that order, but multiplication's commutative, so it'd be okay to switch that around. And then you have one of these and one more of those. So that's going to give you 2 sine theta, cosine theta. So some of the formulas that we get in the next unit are actually able to be proved using these formulas. All right, let's try one more. It's a little more elaborate. All right, what about trying to verify that one of the ones we have in this? What if we're trying to verify that the tangent formula that we're using, what if we try to prove that that's the case? over 1 minus tangent theta, tangent beta. Okay. All right, so we can work on doing that. We're probably going to wind up using the cosine, sum and difference formulas for cosine and sine, which would be fine. So you know that the tangent of alpha plus beta, because of tangent being sine over cosine, you know you could rewrite it as sine of alpha plus beta over cosine of alpha plus beta. All right, so this is what we're working on now. This is the third one. Let me label these. This is the second one. And then we did one here. Okay, so we get that far. All right, then next what we're going to do, as you might expect, is replace each of those with what the right-hand side for those says. So glance back so you don't make any mistakes at all on that. So sine does sine alpha cosine beta, and then it changes to minus. No, it stays plus, I mean, cosine alpha sine beta. Okay, so we were doing sine on top, and that's what it looks like. And then for your cosine, one, you're doing the cosine of a sum, so that would be cosine alpha, cosine beta, sine alpha, sine beta, but that would be minus right there, okay? And then you kind of glance at what you're ultimately trying to get. Okay, so that sometimes helps you, just trying to think about what you're trying to get up there at the top. Oh. And you try to think about how you can, where you can go from here. You know, what are some options that you could do at that point? Right, so looking at that, I'm playing around a little bit because I'm trying to figure out how to get tangent right here is what I'm looking at. So I have these two terms, and I'm trying to think about how can I turn that into a tangent. So I would need a cosine on the bottom, and I'd need to get rid of a cosine on the bottom. So it's like I'd need a cosine alpha and a cosine beta there. So I'm looking at what I would need to make that turn out to be tangent of alpha. And right here, underneath here, I would like it to have a cosine alpha, cosine beta, okay? But I can't just do that in one spot. So I'm going to divide everywhere by that, okay? So bear with me. All right, so that was my kind of my reasoning for why I'm doing this. Okay, so let me get these written real quick. So here's the old numerator. And what I want to do is I want to have this one divided by cosine alpha, cosine beta, because that would be a way of getting tangent right there. But if I do that in one spot, I have to do that everywhere. And I have to do that not just on top, but also on the bottom. So here's the original denominator divided by cosine alpha, cosine beta on both of these. All right, then let's look and see what happens. So yeah, so that's gone. That's gone. This is gone and that's gone. And over here, nothing's gone. Okay, so let's see where we're at that point. Let me just clean it up a little bit. Sine theta over cosine, sine alpha over cosine alpha, even though I know that's going to be tangent, I wanted you to see that. And then here I have sine beta over cosine beta. And then in the denominator, this doesn't go away to where you don't have anything, but it equals 1 now. And then here, nothing canceled out. I had sine theta, sine beta, cosine alpha, cosine beta. I keep saying theta instead of alpha. All right. Okay. So let's see if we can see. There's just one more step. I think I can just squeeze it in right here, because isn't this tangent of alpha? Isn't this tangent of beta? Okay. We have the 1 minus, and then isn't that tangent alpha, and this tangent beta, but there's a times in between them. There you have it. So we just proved the formula for the tangent of alpha plus beta. We proved it using the sine and the cosine formulas. And really, we could keep backtracking and proving those. And if you're interested in the derivation of all the formulas, you can read section 6.2, because they justify and try to verify the formulas. All right, so that's it on 6.2.